Okay. So here's a mechanics question. And it's actually much simpler than it looks. So a large bucket is used by a crane on a building site to move materials between the ground and the top floor of the building. The mass of the bucket is 15 kilos. The bucket is attached to a vertical cable at the bottom of the bucket. With the bottom of the bucket horizontal, the cable is modelled as light and inextensible. So let's try and redraw this. Okay, so we've got a cable which will have tension. We've got our bucket underneath. Okay, and the bucket weighs 15 kilos. When the bucket is on the ground, a large bag of cement with mass 25 kilos is added to our bucket. The bucket with the bag full of cement moves vertically upwards with a constant acceleration of 0.2 meters per second. So it's going up 0.2 meters per second. Air resistance model is negligible, so we can forget that. A, find the tension in the cable. Right, so this is pretty straightforward. So what do? We've got our diagram. Check. Okay, we need to then decide on a direction. Well, as it's moving upwards, and the tension is moving upwards, I'm going to pick it upwards. So I've got my direction done. Now, I know that basically I've got a force and I've got acceleration and I want the tension, so I'm going to use F equals ma. So I have an equation. Right, now I'm going to substitute into my equation. So in the upward direction, I've got tension is positive. I've got two weights weighing me down. So that's minus 15g and minus 25g. And that's equal to the mass, which is 15 plus 25. Remember, there's no g because this is just mass. And I multiply that by the acceleration, which is positive in the direction that I've chosen. So I've got t minus 40g equals 40 times 0.2. And I'll rearrange that. And my tension is equal to 400. And I must remember my units, newtons. Okay, so that's pretty straightforward. That's A taken care of. Right, now for B. At the top of the building, the bag of cement is removed and a box of tools with a mass of 12 kilos is put in. So, you know what? I'm going to draw another diagram. So I've got tension. I've got my bucket. And inside my bucket, I've got my box of tools, which weighs 12 kilos. Okay. Air resistance again is negligible. The bucket with the box of tools is moving vertically downwards with constant deceleration. So it's moving downwards, but the acceleration is minus 0.1 because in the downward direction it's deceleration. Right, now I need to find the magnitude of the normal reaction between the bucket and the box of tools. Right, so actually I'm not looking at this. I'm just looking at this reaction here between the floor and the box of tools. Right, so again, I am going to resolve positive in the upward direction. So I've got a direction, I've got a diagram. Okay, I know that I'm going to use F equals ma. So I've got an equation. Okay, so I'm going up, and my R that I want is positive. Okay, I've got 12g going down. That's the weight of my box of tools. And remember basically that the normal reaction should be equal and opposite, except when it's moving. So that's R minus 12g. That's my forces. Now I've got the mass, which is 12 kilos. And I've got to multiply that by minus 0.1, because remember we said it's going to be, oh, sorry, my apologies, that's going to be positive, because we're going in the upward direction, which means we change the sign. So now I've got R is equal to 12g plus 1.2, which is 12 times 0.1. 12g, 12 times 9.8, that's 117.6 plus 1.2, 118.8. And that's newtons, or roughly 119 newtons. That's my final answer for B. Okay, so each of these questions, what's the important thing? Okay, so each time we found a diagram, we decided on direction and noted it clearly, decided on an equation, and then solved the equation. Okay, remember, read the question carefully. This had downward motion, and on the downward direction, it was deceleration, so that's a negative. Okay, we resolved going up the other direction, so our acceleration became positive. Okay, sign errors are very easy to make, so you have to make an effort to make sure that you're consistent throughout the equation.